Let's say you're planning a trip to a nearby park, national park that is, and you don't know the exact distance to the park. But what you know is within the park, from the gate, we need to travel 15 kilometers to go to a viewpoint that is pretty famous. But you don't know the exact distance from wherever you are staying. The place is new to you guys, and you don't know the exact distance from the place you are staying to the main gate. You go out and ask people what is the distance from wherever you stay to the main gate. So that is the question. You plan a trip to a nearby park according to their website, so the national park's website. You need to travel a fixed distance of 15 kilometers from the main gate to the main viewpoint. The problem is you don't know the exact distance from your house to the main gate. You decide to ask several people in your neighborhood and they are giving you a different number. How can you calculate the total distance you will travel? So let's take up this scenario. Enter the new distance you were told to the park gate. Say someone tells you that, you know what, you have to travel 40 kilometers. So basically 40 plus 15 is 55. You go to another person, he tells, you know what, that road is actually closed. You need to take a detour, that is a bit of extra route, and so it will be 50 kilometers. So what is the total distance you will travel? You will have to travel 50 kilometers and then 15 more kilometers. So this is 50 and then 15. So this will be correct 65, right? So you have to travel 65 kilometers. One more person tells, you know what, I know one shortcut. You don't have to travel so much. You just have to travel 40 kilometers. Sorry, not 40, say 35 kilometers. So what is the total distance from your starting point to the final point? So this will be 40 and 50. So 50 kilometers, right? 35 gives us 50 kilometers. Someone tells, you know what, there is, if you guys are willing, you can go on bikes and it will just take 10 kilometers. So what is the total distance from your starting point to the final point? 10 plus 15, that is, right, 25 kilometers, is it not? Okay, so that's how you can calculate. You just need to add the distance told plus the distance that you need to travel within the park. Now let's have a look at the balloon scenario. You're hosting a party, means there is a function in your house, say birthday party or naming ceremony or something like that, and you want to give each person 2 balloons. Say all the majority of the people who are coming are only kids. So I say it's a birthday party. There's no elders. So each person gets 2 balloons. How can you figure out the total number of balloon you will need without knowing how many people will come? So forget about all of that. Just think about this. Let's not even think about that. How will you figure out the total number of balloons you will need? This, let's not bother. So we're looking at that. Now, if I happen to, if we happen to get, say, 10 people, right? I think about it. I know that 10 kids are coming. So how many balloons do we need? Correct, 20 balloons, right? Because each person will get 2, so 10 into 2. What if you remember, you know what, no, I forgot that building or that place. I remember my college friends, but not, I forgot my school friends. So their kids per se, right? Let me think in that way. So there are 6 more kids that are coming along with the 10 more kids. Then basically we have 16 kids coming in. So how many balloons will we need? Yes, 16 twos is 32 balloons. Then I remember, you know what, I happen to know that my family also has invited around 10 more kids. So we have 26 kids now. So other than me, there are 10 more kids being invited by someone else from my family. So 26 into 2, that would be 52, right? 52 balloons. Now, in both of this scenario, I gave you guys different numbers, like say 10, you multiplied with 2 and you got 20. And say we went on to even 26, even 16 also, if I remember right. Then we have 32. Then we went to 26 as well. Then this gave us 52 and any set of numbers. So what if I tell you that, you know what, only 5 kids are coming. So how many people are there? How many balloons do we need? 10, right? Only 5 kids were there. I'll get 10 balloon. We just need 10 balloons. Now the question is, I have 2 different scenario, and all of the scenario, whatever numbers I put over here, we got the exact answer. Is it not? This too, we got the exact answer, right? How does this work? I mean, basically, what is happening over here? Right? This is just set of numbers and I've written something over here. And the screen is able to give us answer. Like, how is this working? If I gave it some weird number, say it's a very big function and you have 124 people coming in. Say it is some other thing and this is a big fat number that we have. So even then, this particular screen is able to give me the exact answer, right? 12, 3, 3, 4, 3, 2, 2, 4, 6, 6, 8, 6, 4. Number looks right. Say you are traveling question over here. Say you are traveling 12.5 or 78 kilometers. So it's even with any number, even with digits, it's able to give me the exact answer. It just takes a fraction of a second. How is it able to do that? Right? How is this 2 scenarios? I'm able to solve it with just these 2 screens. It's acting like a calculator, is it not? Even calculator does that. So how is all of this working? All of this works with a basic idea of something called as variables. They're nothing but letter numbers, also known as placeholders. They'll hold the place. Instead of using a specific number, it uses a letter to stand for any number. So example, I'll give you this example, travel example. It's over here. Distance to the gate. That is your variable, right? That's the placeholder. Basically, whenever you give any number, the program, this thing will add 15 to whatever value you are giving, and it will give us the total distance. Same thing with balloon also. As you can see, it will be somewhere over here. Yeah. Number of people, whatever we enter, it will multiply with 2 and give us the final answer. It's same thing as what we did over here, right? 10 plus 15, 20 plus 15. But of course, that's in our head. This we can, whatever is there and the way we think in our head, that can be programmed, right? But it's the same funda. Number of people into 2. Here, distance to the gate plus 15. So that's the whole funda. So these are placeholders. Letter numbers are placeholders. So that lets us use any kind of number any point of time and it will give us the right result. So this is how variables work, and that's the role of variables. So what is the advantage? This lets us write a general rule that works no matter what number we plug in. So if you guys know about this, area of a, I think, rectangle is something that you guys will remember. What is the area of a rectangle? Length into breadth, right? And if someone tells length is 10 and breadth is 5, you end up with 50 some unit. I don't know how many of you are familiar with it. These 2 are variables. Okay, so these 2 are, let me use. So these 2 are variables, length into breadth. So these are placeholders. So in this space, whatever value we put, and after multiplication, we'll get the actual area of the rectangle. right? Now, as a definition, letter number or variable, I use this word as well. A letter like A or X or L or B or even an entire sentence is used to represent a unknown or a changing number. Okay, so unknown or changing number, like here I've used distance to the gate. So instead of that, say I do this, instead of distance to the gate, I use X. Okay, so let me do that. See here, X plus 15. And let me, now let's see. Enter the new distance you were told to the park gate, say 30. So remember 30 plus 15, that is 45. Can you see that? It still works. See, it's the same thing. Total distance is equal to X plus 15. So instead of what we had before, distance to the gate, I used that. I used X. If you're not comfortable with X or A or B, you can use this as well in your programs. Generally, people do that itself. But when you're writing and everything, we use small letters. A, B, C, D, whatever you want. Like here I was about to write length and breadth, then I went back to the actual thing that we are learning, that is using small letters to represent scenarios. So L and B. I went back to using L and B. If you guys are not comfortable with this, it's okay to write length into breadth. But yeah, here it is preferred that you use small letters. When you're writing on a sheet of paper, it's preferred to use small letter. When you're coding, the standard is to write the actual variable itself, what the variable stands for, rather than using X or A or B or anything. Now, algebraic expression are the mathematical phrases that combine the letter number or numbers and operation, like plus or times or whatever. What does that mean? In this case, let me take a screenshot. How visible this is to you guys. This is an example of algebraic expression, this entire thing. And this is your variable. It's not a letter over here, it's a phrase, but still that's a variable. So algebraic expression is made up of variables and operations. You can see operation, addition operation added to a number, right? So you have all of that combined to give us an algebraic expression. So these are the two definitions that we need to know. So let me pick up one more example. You go for a morning run or morning walk and cover a distance of 3 kilometers every day. So actually I do this. I go for a run and around a lake actually. And by default, whatever I do, if I complete the entire circle, I will be covering 3 kilometers. Okay. So how will you figure out the total distance you have walked over any number of days? Okay. Let me put it in this way. Say I happen to walk for 3 days. Right? The total distance traveled by me is, or total length or distance walked by me is 9 kilometers. What if I remember that, no, I was also on a walk another day of that week. So basically 4 days is what I walked. So what is the total distance? Yes, 12 kilometers. Because every day I walk for 3 kilometers. So if I walk for 4 days, 4 into 3, 12 kilometers. So now I'm thinking, okay, last 2 weeks, how much did I walk? So 4 days was last week. Last to last week would be, again, I think I went for 3 days. No, 4 days. So 8 in total. Last 2 weeks I walked for 8 days. So 8 threes are 24. See, again, this program is able to help me calculate within a fraction of a second. So for starting of the year, I have walked for around 30 weeks. So approximately 90 days I walked, for example. Again, fraction of a second, it gave me 270, right? Honestly, it's not 3 kilometers. It's around 2.15, right? 25. It's with decimal. Okay. So let me stop this. So decimal is not a simple thing to handle, right? You just got introduced to the idea of decimals. Think about multiplying with decimal. So I worked for 3 days, and you can see that it's able to give me the answer. I worked for 4 days, it's able to give me the answer. Then I remember 8 days, this is the actual distance I am walking. Then I remember that last 1 month I walked for 18 days, and you can see it's still giving me the answer. So you can see that just by using the variable along with set of numbers and operations, that is having a expression like over here, and just changing one number, I'm able to calculate any weird scenarios. That is the power of using all of this. That's why we're learning this. So see, I don't have to be that well versed with multiplication and division with very complex numbers, but I have to be smart enough to build something like this. And that's what we are trying to learn. So what are the letter numbers or the variables that we used over here? So let's have a look. So I don't know if it's big enough for you guys. Here it is the number of days. Again, in program, we generally don't use A, B, C, D and all of that. We use the entire phrase. So it's number of days. Okay. And what is the algebraic expression that we used over the number of days into 2.25? For this question, it will be into 3. Originally, it was 3. Okay. So number of days into 3. Total distance is equal to number of days into 3. So the variable that we used over here is, technically I used variable used is number, oh, I don't have space for that, number of days, right? That's how it's over here. Yeah. And the expression is, algebraic expression is number of days into 2 point, or not 2 point, sorry, 3. For this question, it's 3. So this is the algebraic expression that helped me calculate. Okay, guys. So we have one last example. So wherein I'm not using any program, I'm just talking about pen and paper. Let's say Aftab's age is 8. His sister Shabnam, right, is always 3 years older because she was born 3 years before him. So she's always 3 years older. So instead of saying if Aftab is 10, is 10, Shabnam is 13. If Aftab is 15 and Shabnam will be 18, right? If he is 10, she will be 13. If he is 15, she will be 18. We can write a simple rule that Shabnam's age plus 3 is the sister's age. Okay. So if A is 10, here we are using A as the letter number. That is Aftab's age. So I didn't mention that here. A is, sorry, Aftab's age. Okay. So that we have to keep in mind. So whatever Aftab's age is, the expression, this is the algebraic expression. A plus 3, it will give us the exact answer. Letter A is the letter number or the variable. A plus 3 is the algebraic expression that works for any age. Right? 10 years down the line, say today Aftab is 15, 10 years down the line is 25. His sister will be 28, whatever the scenario is. So this is the entirety. Okay, this is what is your notion of letter numbers. So letter numbers are used in here, right, to solve such a complex scenario. It's used over here. To be honest, these are set of simple programs. If you build a complex program, it will make up the devices that you guys are using. Your devices is also using this letter number. The way it works, it's all dependent on this letter number, that is variables. Okay. So it's a very important tool to learn. So put your effort in learning. Try to do it without me pushing for it.